Hi, my name is Matthew Pathiel. Today we'll be discussing some of the concepts behind data analysis, the several steps needed to be taken with the data analysis process, as well as data analytics, data mining, and cognitive computing. Data analysis is the process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decision making. The use of data analysis has been around since ancient times. However, the rise of computer and internet allowed for data analysis to be incorporated in the electronic computing industry. There are several phases included in the process of data analysis, such as data requirements, data collection, data processing, data cleaning, exploratory data analysis, modeling and algorithms, data product, and communication. Under data requirements, data must be specific to the needs of the person doing the analysis or the user of the final product of the analysis. There are two types of data that can be collected: quantitative data and qualitative data. So what's the difference between the two? Quantitative data indicates anything that can be measured numerically, such as your foot size, your height, etc. Whereas qualitative data is more descriptive and includes things that are harder to measure, such as color, race, gender, etc. The second phase of data analysis is data collection. Data collection could be conducted from a plethora of sources. Collection can be conducted internally from the drivers of the analysis and/or be collected from outside vendors such as traffic cameras, satellites, and recording devices. The third phase of data analysis is data processing. Processes of data analysis depends on taking data and in its entirety and breaking it down into individual and simpler components for observation. These processes also allow for raw data to be obtained and converted into information useful for decision-making users. Data processing has also led to the rise of commercial data processing, which involves a large volume of input data, relatively few computational operations, and a large volume of output. Packages like SPSS or SAS are commonly used. After data processing has been completed, the data must be cleaned of incomplete, duplicated, or data that is errored. Some methods to clean data include record matching, deduplication, and column segmentation. The exploratory data analysis phase can now be conducted to decipher any messages encoded in the data. Descriptive statistics such as average or median help measure this kind of data. As a result, data is modeled and applied to algorithms to seek variable relationships such as causation and correlation. With models and algorithms, inferential statistics can also be applied, which include techniques to measure relationships between particular variables. Once a model or algorithm is created, a final data product can be issued that takes the data inputs and turns them into outputs. In the final phase of data analysis, the analyst will utilize methods using data visualization to communicate the data to the user of the final product. One way to communicate data is with data visualization. Data visualization uses information displays such as tables and charts to help communicate key messages contained in the data. Within data analysis, there are three subcategories including data analytics, data mining, and cognitive computing. Data analytics is the discovery and communication of meaningful patterns in data. Analytics focuses on the inference, the process of deriving a conclusion based solely on what is already known to the researcher. Analytics often relies on data visualization more and includes a variety of disciplines. Sectors of analytics include risk, digital, security, and software analytics. Another faction of data analysis is data mining. Data mining is the computational process of discovering patterns in large data sets and utilizing its methods for artificial intelligence, machine learning, statistics, and database systems. Data mining extracts some data to transform it into better comprehension. In history, similar terms have been used to describe this concept, such as data fishing or data dredging. The last subcategory is cognitive computing. Cognitive computing takes human problems and apply them to computing. Cognitive computing must have adaptive, interactive, iterative, and stateful and contextual properties in order to be achieved. For cognitive computing to be adaptive, it must learn as information changes and as goals and requirements evolve. For cognitive computing to be interactive, it must interact easily with users so that users can define their needs comfortably. It may also interact with other processors, devices, and cloud services. To be iterative, it must aid in defining a problem by asking questions or finding additional source inputs if a problem statement is ambiguous or incomplete. And finally, its contextual property allows it to understand, identify, and extract contextual elements such as meaning, syntax, time, etc. So what does this all mean for the future? Data analysis is involving business intelligence and the ways corporations operate. And internet databases with variable and dataset ontologies are beginning to rise as a result.